This video will demonstrate how graphical calculators can be used by students to investigate mathematical ideas. A graphical calculator is a really powerful tool with which to encourage students' use of technology. Students have ownership of the mathematics, and the process of constructing the mathematical objects on their calculators aids the process of students constructing their own understanding of mathematical relationships. Here, you will see a teacher guiding students through a task investigating the factor theorem with graphical calculators.
Would you like to set up on your calculator x cubed minus 2x squared minus x plus 2? Set up your table to start from -5, end at 5 and go in steps of 1. When you've done that, if you go across into the graph mode and use the draw button, and up comes the graph. Would you look at those and discuss in pairs? Anything that you can see comes from both the table and the graph.
1 minus 1 and 2. Okay, and then you can tell that there's a maximum as well. It's just over 2. I'm checking on the table there.
Our function actually factorises to x plus 1, x minus 1, x minus 2. Would you discuss with each other as to how you might have realised that?
If any one of these brackets equals 0, then the equation and y must equal 0.
X values are the solutions to each of those brackets equaling 0, and those were where the intersection was between the graph and the axis, and it's quite amazing.
Any offers as to something you can see using the graph and the table?
On the graphs and the tables, you can see that y equals 0 at -1, 1 and 2, and that's shown on the table as well.
Right, I can see on the graph that y equals 0 at -1, 1 and 2.
Yeah.
How can you see that on the table?
On the top left, it shows that the value of y is at 0.
So y equals 0 when x is -1, 1 and 2.
Yeah.
Good. Anybody else tie that in with this equation?
Those x values are the solutions to each bracket equaling 0.
So if x plus 1 equals 0, then x equals
Minus 1,
-1, this bracket,
plus 1,
and x minus 2.
plus 2.
Would you now find the factors to factorise these following cubics?
Yeah, shocked by it.
Oh.
Execute. I've done x cubed minus x squared minus 8x plus 12.
And that's a tricky one, is it?
This gets only 2 roots, so I can't put it into the form of 3 brackets with the form.
So what are you going to do?
Well, I can't just put x out because that would prefer 0, and I just...
Do you know what the graph would look like? So if we look at the graph now, explain what you see there.
Graph just touches the x-axis at 2, so 2 of the factors will be 2.
What's our first factor?
X plus 3, x minus 2, and x minus 2.
And can you all see, tying in the table and the graph allows us to see that so quickly. The fact that they were able to see the results for their graphs and investigate at their own pace, that generates their own interest. They can actually, during a lesson, if they're doing a question, think, oh, I'll do the table function on this, or I'll do the graph function on this.
And what do you think any of the issues or barriers are with using graphical calculators in the classroom?
Accessibility, and initially learning the basic techniques how to use a graphical calculator. Where do you keep your graphical calculators? Do you have to carry them around with you? Are they available in the classroom? If they're not available in the classroom, then you're less likely to use them when you need them.
And so thinking of yourself as a teacher, does that mean that you teach differently when they have graphical calculators? Does it change your classroom practice?
It allows me to set them questions where here's the answer, what's the question? Or how many cubics can you find that go through these 3 points? The conversations that generates between the pupils where they're using their calculators just as they would a normal calculator, but drawing graphs, looking at tables, it brings the lesson alive.